All right, guys, here we go. Number one. We're given a polynomial. We're asked for some different pieces of information here. So let's start with the degree. So this is what's known as standard form here, excuse me. Nothing is factored. Right, so because nothing is factored, we look for the largest exponent here. Okay, that number is our degree. And because this number is odd, it tells us that the ends of the graph are going to go opposite directions. Now, before I get the end behavior, using limit notation, I am going to find the leading coefficient. So the leading coefficient is not the number in front necessarily. It's the number in front of, when it's in standard form here, the number in front of the x with the biggest exponent. So our leading coefficient is 1. So because this is positive, it tells us the graph is going to finish up to the right. Remember, leading coefficient actually tells us how the graph ends to the right. A positive, up to the right. Now, because the degree was odd, the ends are going to go opposite directions. Well, if it ends up to the right, it's going to start down to the left, like that. So if this is our end behavior, what coordinate points are these approaching? Well, this is, if it's on an xy axis, right, this graph here is approaching negative infinity for x, negative infinity for y. And so that goes in our limit statement for the end behavior. So x is going to approach negative infinity, and y is going to approach negative infinity. Now, as it goes to the right, the graph is approaching positive, positive infinity. So those values will go in the other limit statement, positive, positive. Part D, this is a cubic function because the degree is 3. All right, oh, and that's wrong. That's not cubic. So, number 2, the degree. This time it is the leading term, right? That's the biggest exponent. So the degree is 4. Because this is even, that tells us the ends will go the same direction. Our leading coefficient is the number in front, which is negative 5. Now, because that number is negative, what does that tell us? It tells us the graph finishes down to the right. Well, if the ends go the same direction, if it ends down to the right, it's also going to start down to the left. Okay, so this is our end behavior, but in limit notation, right, this is the same as the last one. We're approaching negative, negative to start. All right, so here's our limit notation. But this side is approaching positive infinity, negative infinity as a coordinate point. Right, remember, think about this on the xy axis. Right, so we're going right forever, down forever. Positive, negative would be the sign in quadrant 4. All right, so x is approaching infinity, y is approaching negative infinity. Again, this is just a coordinate point. Right, I take the x coordinate right there, and that's that x coordinate. And then we take the y coordinate, right? Take this y coordinate, and it's going right there. Again, this is just a coordinate point that we approach, is all that is. All right, up next, D. We've got an exponent of 4, so this is called quartic. Quartic, when that happens. All right, number 3. Now, you can do this with a graph, but my preferred method is a number line, and so that's what I'm going to show you guys. I think it's easier. You don't need as much information to do the number line here. So what you do have to start off with are the zeros. So this doesn't have an x, so it doesn't give us a 0. These 3 all have an x, and so we take the opposite of what's inside. So x equals 4 is a 0, x equals negative 1 is a 0, and x equals 2 is a 0. Also, negative 1 is going to bounce because it had an even exponent. The other 2 are going to cross, and cross. So let's put these in order here. So negative 1 goes first, then 2, then 4. Now, when starting with the signs here, again, we look at the leading coefficient. So the leading coefficient's negative. That negative does not go at the beginning, it goes at the end. So there's a negative right here. Now, anytime the 0 says that it's going to cross that means at that value, the graph is going to change signs. So at -4, the graph crosses. So if it's negative on the right, it will be positive on the left. 2 also crosses. So if it's positive on the right, it'll be negative on the left. But -1 bounces. That means it's the same sign on both sides of -1 here. So if this side is negative, this side is negative. Now we're looking for greater than or equal to 0. That would be the positive portion. And so the positive portion is right here, including the endpoints. And so that's why our answer is 2 to 4. 2 to 4, like that. Next question, same thing. There's not an x here, so I do not set this part equal to 0. I'm going to set x minus 4 equal to 0 to get 4, and set x plus 1 equal to 0 to get -1. So on the number line, -1 goes first, then 4. Our leading coefficient is still negative, so I still put a negative all the way over here on the right. 4 is going to cross because it had an odd exponent. -1 is going to bounce because it had an even exponent. So the graph will cross at 4, it will bounce at -1. So if to the right there's a negative, okay, the graph is going to cross. That means it changes signs at 4, and we're going to put a plus here. If it bounces at -1, sign's positive here, it's going to be positive right here as well. Okay, but now we're looking for less than 0. So where's it negative? Well, it's negative over here. But we're going to exclude that point, right? Because this point, the graph is actually at 0. That's why we found the zeros at the beginning. So how do we do this as an interval? Well, I'm going to start at 4, and the graph goes right forever towards infinity. So those would both get parentheses. Infinity always gets parentheses. 4 gets it here because we're not including the 4, right? It was just less than 0, not equal to. All right, number 5, we're told that the degree of a polynomial is 10, and we're given 3 of what's called the real zeros. These are the only real zeros on the graph. Now, what's supposed to happen is our multiplicities are supposed to add up to the degree unless there's imaginary zeros or non-real zeros. So the multiplicities only add up to 4 here, right? So it's supposed to add up to 10, but it added up to 4. So 1 plus 1 plus 2 is 4. That tells us if we were to subtract those two numbers, right? If we take the degree and subtract the sum of the multiplicities, that gives us the number of non-real zeros. Okay, so our answer is 6, because again, those numbers, if there were not any non-real zeros, these numbers would add up to 10 here. Multiplicity should add up to the degree unless we're missing some non-real zeros like we are here. Number 6, if this is a 0, remember imaginary numbers are always plus or minus. Imaginary zeros, I should say, are always plus or minus. So it's -4 plus I is the other 0. The -4 does not change, but the I changes sign. So that's our other 0 right there. Don't be surprised if this question on the test, there's a lot of other information you don't need, but if you see that this is a 0, you know that that's a 0 as well. All right, so the last 2 questions for this video, because I don't have time this morning to do all the questions, so I'll try to get to that hopefully Tuesday before class. But let's see, so number 7, we're given a table where asked for the degree. And so we start doing what's known as successive differences. Okay, we can ignore the x's because they're all equally spaced. To get from 96 to 54, we have to subtract 42. And then we have to subtract 30. And then we have to subtract, let's see, what would that be? 18. Okay, so the fact that these are not the same tells us it is not linear. It's not linear. Okay, then we do it again. Well, I subtract 12 and I subtract 12. Well, these are the same. So that if it's on row 2, that tells us it's quadratic. Okay, and so what's our degree? Well, our degree is 2. Or I could ask for the type of the polynomial, it would be quadratic here. Okay, I have to give us more numbers, but if this kept going, if the numbers in the 3rd row were all the same here, well, then it would be cubic, or having a degree of 3. And if those weren't the same and the numbers in the 4th row were the same, then it would be quartic, right there. Okay, but ours was quadratic, degree of 2. All right, number 8, are these even, odd, or neither? So remember, if all the exponents, we're not adding them, but if all the exponents are even, it's called an even function. If all the exponents are odd, it's called an odd function. If there's a mixture, it's neither an even function nor an odd function. Now, don't confuse this with degree. It could be neither, but still have an even degree or odd degree. Okay, we're talking about even functions versus odd functions here. So, question A, we've got x squared plus x to the first. Well, here, while the degree is even, right, the degree is 2, we've got a mixture, so it's neither an even function nor an odd function. So this one's neither. B, we've got a constant. If a constant is by itself, it has an x to the 0. All right, so we're going to view that as being an even function because of that 0. Even. Part C, we've got an x to the third and a x to the first. The numbers in front don't matter. This is going to be odd because both exponents are odd here. Okay, odd function. And the last one, we have an even degree. Even, it's only one exponent and it's even, so it's an even function. All right, guys, so that's it for this video. Again, I will hopefully either after school today or before school on Tuesday get to record the rest of this. But if not, I'll answer those questions in class, guys. All right, stay flawless.